right, so we worked last time to create an equation of the line that best fits our data. So just to refresh your memory, last time we were looking at our data set from Monopoly, the number of spaces versus the cost of a property. And we ended up finding this line that best fit the data according to our least squares regression. So what we have here is the equation of that line. The predicted cost is equal to 67.28 plus 6.78 times the number of spaces from go. One thing you're going to be asked to do with an equation is to actually interpret it, to explain what it means. I know you can punch the buttons in your calculator and find the equation, but can you explain it? So the first thing I'm going to ask you to explain is the Y-intercept. The Y-intercept. That is the constant, the number that's alone and not next to the variable. Now, I said be smart. These don't always make sense, and I will show you what I mean by explaining or interpreting this one. So just to refresh your memory from algebra class, the Y-intercept is where my line crosses the Y-axis, okay, right here, right here. You'll notice at this location, my x is 0. Okay, right here, x is 0 when I cross the y-axis. So I'm going to explain that in words. When my x value is 0, what is my y value? But of course, I'm going to do it in context. In context. Means I explain the story problem as I go. So I said it's when x is 0, y is, well, this number, 67.28. But that's not in context. X and y could be anything. So I need to put it in context. When I'm 0 spaces from go, okay, that's what the x variable was, the number of spaces from go, and it needs to be 0. A property will cost 67.28. Okay, notice my y changed into the cost. And I want to be really clear here. It's not 67.28 elephants or 67.28 bananas. It's 67.28 Monopoly dollars. And so that's what it means. When I'm 0 spaces from go, it's going to cost me $67 to buy a property. Now, I said it doesn't always make sense, because if you've played Monopoly, if you're 0 spaces from go, that means you're on go, and you can't actually purchase the go space. So here's an example where it doesn't really make sense. But that's okay, we've still explained it. And it's okay if you want to say, this doesn't work because you can't buy the go space. That's okay. You can acknowledge when the y-intercept doesn't make sense. The other thing you're going to be asked to explain is the slope. The slope. Slope. Slope is the number in front of your x variable. And you've probably never been asked to interpret a slope before. So just to be real clear, the slope is 6.78. Just going to write that down so that I can move my screen a little bit. You've probably heard of slope as being rise over run. So it might be helpful if I showed you our slope as a fraction, rise over run. Rise on the coordinate plane is the y, and run is the x. So we're changing 6.78 in the y direction per 1 in the x direction. And that's what's going on here. That's why I wrote y units per x unit. Y is changing or rising this much when x changes 1. When x changes 1. Of course, I need to somehow say that in context. So 6.78 is my y Remember, y is my cost. So cost, I could say changes 6.78, but I want to be more specific. It's a positive number, so that means it's increasing. Cost increases $6.78 per 1x. Per 1x. Well, x, remember, is the number of spaces. So it's changing every one space I go. So cost increases $6.78 for each one space from go. Basically, I'm saying every time I move, right, here's go. If I move one space, the property is going to cost me, well, another $6.78. And whatever it was, the next space is another $6.78 higher. And then the next space is another $6.78 higher than the last. Each space I go is another $6.78 to buy the property. Now, if we actually go back and look at our data, wow, it's been a long time since we looked at the original data set, you'll notice that's not actually happening. Space number 1 is $60. Space number 3 is still $60. I didn't increase this 6.78 per space. So I just want to acknowledge that as I'm explaining my slope here. And that's what I call these, I call them weasel words. Actually, your author called them weasel words in a correspondence I had with him. I would rather call them wiggle words. Gives me what I think of as a little bit of wiggle room. This is not perfectly true. So if I add some wiggly words, it makes me sound like I'm no longer a liar. So a wiggle word might be something like this. Cost increases about $6.78 for each one space from go. Other common wiggle words are on average, or you could replace about with approximately. Those are great wiggle words, or weasel words, as your author called them. So I just want to look at a couple more examples to help you practice this. So believe it or not, some people say you can estimate the temperature outside based on the number of cricket chirps you hear. So after doing this process of creating a scatter plot and a least squares regression line, I have this equation. The predicted degrees outside in Fahrenheit is equal to 40 plus 0.25 times the number of chirps I hear. Okay, it's real data, real data. So I'm going to interpret the y-intercept in context. So remember, the y-intercept is the constant. It's the number that's all by itself. And the y-intercept is what our y value is when x is 0. So when x is 0, well, x, remember, x is my number of cricket chirps. When there are 0 chirps, well, the y-intercept tells me what the y value is. The temperature is 40 degrees Fahrenheit. By the way, that kind of makes sense to me. 40 degrees is kind of cold, so I'm hearing 0 chirps because probably there are no crickets outside because it's very cold. So I like this one. Y-intercept kind of makes sense to me. I could hear 0 chirps and I could have a temperature of 40 degrees. It makes sense. The slope, please recall, the slope is this value in front of the x variable. And remember, this is y units per x unit, rise over run. So I have 0.25 over 1. So my temperature, because that's my y, my temperature goes up 0.25 degrees for each one cricket chirp. All right, And by the way, the number of cricket chirps, I'm sure, is in some set time period. I apologize for not getting that information up there. Now, the last thing I need is some, of course, weasel word, like approximately 0.25 degrees for each cricket chirp. Okay, make sure you acknowledge this situation is not perfect. My equation is not a perfect representation of the real data. All right, so I do actually have one last example, and I'm going to ask you to try this one. Remember, you have two things to do: interpret a y-intercept and interpret a slope. All right, so for example number 3, here's our last example. Perhaps there's a linear relationship between the number of baseball games won by American League teams and the average attendance. This is actually in your book, page 190, number 16, if you want to take a look at the data. And here's the equation or the model we end up with. We think we can predict the attendance by taking 5,773.27 plus 517.61 times the number of wins, probably in a season. So to interpret the y-intercept, remember that's this value here by itself, that's what is y when x is 0. So when x is 0, when there are 0 wins, oh, poor team has 0 wins, attendance is, well, you can't have 5,773.27 people, so I might insert a word like about, because there's not 0.27 of a person. But this really makes sense to me. Even a team that never wins, people still come to their game. That makes sense. The slope is this value in front of the x variable. And remember, it's y units per x unit. All right, so I can say something like attendance increases. I'm using increases because this is a positive number. Increases 517.61 people for each, well, for each, what's my x variable? Win. For each one additional win. Wow. So every time they win, more people come. That makes sense to me. Don't forget to include those wiggle words. And I don't care, I don't care if you put them in like I do with carrots. Increases about 517.61 people for each additional win on average. Sure, write them in after the fact. Just don't forget them. It acknowledges that our model is not perfect.